Welcome to the channel. Today we are going to discuss Hess's law and how to calculate the enthalpies of formation and combustion. So first let's look at the definition of Hess's law. Hess's law states that the overall enthalpy change for a reaction will remain unchanged irrespective of the route taken for the reaction. Let's take an example of a reaction of A and B to form C and D. The enthalpy change for this reaction can be written as delta H1. Now, there can be a second route to form C and D. So, A and B can first form E and F, and E and F can then go on to form C and D. And we'll call this enthalpy changes delta H2 and delta H3. Hess's law states that the value of delta H1, which is the first route to make C and D, should be equal to the value of delta H2 and delta H3, which is the second route to form C and D. Let's take a practical example of this. So in this question, you have been given the enthalpy change of the reaction of magnesium oxide with HCl, and you have to find the enthalpy change using the enthalpies of formation. So you've been given the enthalpies of formation of magnesium oxide, HCl, magnesium chloride, and water. So let's see how we solve this problem. Let's start by understanding the definition of the enthalpy of formation. The enthalpy of formation is the enthalpy change when 1 mole of a compound is formed from its elements in their standard states under standard conditions. So main thing to remember here is that you're forming a compound, only 1 mole of a compound, no more than that, from its elements in their standard states. We are going to use the 3-box method to work out the enthalpy change for this reaction. So the box on the left, you write the reactants, and the box on the right, you will put the products. Once you have that, you put a third box on the bottom, which is going to represent the elements in their standard states. In our case, we have the elements of magnesium, which is a solid, oxygen gas, hydrogen gas, and chlorine. So when you write a balanced Hess's law reaction, the moles in the elements box must match with the moles of reactants and the moles of product. Now, because you're forming your compounds from the elements, you draw your arrows going up from box 3 to box 1 and box 2. So for enthalpy of formation, the arrows always point upwards from the elements box. Now we are going to call the 3 enthalpy changes A, B, and C and try and work out 2 routes that have the same enthalpy change. To do this, you look at 2 arrowheads which point in the same direction. So for example, B and A point in the same direction. So that ends up becoming route 1 and C ends up becoming route 2. Now we can write an equation to say that A plus B is equal to C. Therefore, A is equal to C minus B. So the enthalpy change of A is the difference between the enthalpy change of C and the enthalpy change of B. Now looking at our data, we have to work out the enthalpy change for B, which is for 1 mole of magnesium oxide and to form 2 moles of HCl. Similarly, on the right hand side, we form 1 mole of magnesium chloride and 1 mole of water. So you add up these enthalpy changes and you get a value for B and C. Next, you simply slot these values into the equation. So you get minus 928, which is C, minus 786, which is B. And the difference between the two is the value for A, which is what we have been asked to find out in this question. So our answer is minus 142 kilojoules per mole. Let's look at a second example. This time we have to find the enthalpies of formation given the enthalpies of combustion. So again, first let's look at the definition of the enthalpy change of combustion. The enthalpy change of combustion is the enthalpy change when 1 mole of a compound is fully oxidized or fully combusted in oxygen to form its corresponding oxides. For example, nitrogen would get oxidized to either NO2 or NO3. Hydrogen is oxidized to water, and sulfur can be oxidized to SO2 or SO3. And if you have carbon, then it is most likely to become carbon dioxide. Once again, we are going to use the 3-box method to work out the enthalpy of combustion. So in box 1, you write the reactants. In box 2, you're going to put your products. In box 3, we are going to put our combustion products, which is our oxides. So carbon forms carbon dioxide, hydrogen forms water, and sulfur forms SO2. Remember to balance your elements with the reactants and products. The only thing that doesn't need to be balanced is the number of oxygens because it is in large excess. Now we're going to put our arrows, and because we are combusting the elements, we put the arrows facing downwards. So for enthalpies of combustion, the arrows always face downwards. Now let's try and figure out the two routes for the reaction. So look at the arrowheads. You can see that the arrowhead pointing to C2H5SH and the one pointing to the oxides follows the same direction. So they form one route. So let's call that enthalpy change A and C. And therefore, the enthalpy change represented by B is root 2. So now we can write an equation to say root 1 is equal to root 2. This time we have B is equal to A plus C. Rearranging, we get A is equal to B minus C. Now we are going to put the values in from the table. So B represents the combustion of carbon, and then we add the combustion of 3 hydrogens and the combustion of 1 sulfur. Add these values up together. C represents the enthalpy change of combustion of C2H5SH, which is given to us. So there's no calculation needed there. Now we take these values and slot it in the equation. So B is minus 1943 minus 1170, which gives us a difference of minus 773 kilojoules per mole. That is A, and that represents your enthalpy of formation of C2H5SH. I hope you found these two examples useful and it has given you a better understanding of how to solve Hess's law problems. If you have any questions, feel free to leave them in comments. And if you have any other topics that you'd like me to prepare some videos on, put those in comments as well. Or you can contact me on my website, which is onlinebiologyandchemistrytutor.co.uk, where there's a link below in the description. Thank you for watching.